Imagine this. You wake up on an ordinary morning, you shuffle into the bathroom while still half asleep, you turn on the tap and nothing comes out. Not a drop. No warning, no explanation. The silence is deafening, the pipes are dry. It sounds like a scene from a dystopian movie, but it is not fiction. This exact moment has already played out in major cities around the world. Cape Town, South Africa came within days of running out of water in what they called Day Zero. Sao Paulo in Brazil, a city of 20 million, had taps running dry. And Chennai, the sixth largest city of India, experienced a severe water crisis in 2019. So here's the uncomfortable question. Could this happen to your city next? In this video, we are diving deep into the global water crisis, what's causing it, how bad it really is, and what we can actually do about it. This is something everyone, from policymakers to everyday citizens, needs to understand, because the clock is ticking. Hi, my name is Amin Tali and you are on my YouTube channel Water Edu Hub. Whether you are a student, a professional, or just a curious mind, this is your place to learn, grow, and stay ahead. From hydraulics, hydrology, and flood forecasting to water resources management, water pollution, and climate change, we break down complex water challenges into practical insights. Bridging theory with practice, one video at a time. Stay with me. Planet Earth, from space, looks like a beautiful blue marble bursting with oceans, lakes, and rivers. Water covers 71% of our planet. Yet here's the catch, 97.5% of the water on Earth is salty, locked away in oceans. That leaves just 2.5% as freshwater. But there is more to this. Nearly 69% of the freshwater is frozen solid in glaciers and ice caps far out of reach. The other 30% is hidden underground as groundwater, some of it accessible, but much of it deep and difficult to tap. So, what's left? Just around 1% of all freshwater on Earth is available as surface water, lakes, rivers, and reservoirs. This means less than 1% of all that water available on Earth is fresh and yet accessible, the kind we rely on every single day to drink, grow our food, power our cities, and fuel our industries. And even that tiny fraction is under pressure. Today, over 2 billion people, that's nearly 1 in 4 of us, live in countries facing high water stress. In some regions, taps already run dry for hours or even days at a time. And the challenge is about to get even bigger. By 2030, experts warn that global demand for water could outstrip available supply by as much as 40%. Imagine that, 40% more need, but no more water. So, what's causing this crisis? It's not just one thing, it's a perfect storm. Population growth is exploding, billions more people needing water for homes, food, and energy. And on the other hand, urbanization is swallowing up natural landscapes, reducing the land's ability to absorb and store water. Pollution is poisoning rivers, lakes, and groundwater, making once safe sources unusable. And climate change is reshaping rainfall patterns, drying out some regions and flooding others. Next is lack of data and modeling challenges. At the heart of water management are hydrological and climate models. These sophisticated tools enable us to simulate watersheds, forecast river flows, and inform decisions about dams, reservoirs, irrigation, and other related issues. But here's the catch, a model is only as good as the data you feed it. And in many parts of the world, that data is missing, sparse, outdated, or unreliable. We have rivers without gauges, groundwater tables we barely monitor, and rainfall data is stuck in paper archives. Without reliable inputs, even the best models become guesswork. But perhaps the most surprising villain is inefficiency. Outdated infrastructure, wasteful habits, and poor management that lose billions of gallons of water every single day. This is the global water picture today. a precious finite resource facing growing demand, shrinking availability, and mounting threats. The bottom line, we don't just face a water shortage. We face a crisis of information, infrastructure, and insight. As you saw, the water crisis is real, but so are the solutions. Across the globe, people, communities, and governments are stepping up, embracing smarter ways to secure our most precious resource. Let's explore what's being done and what's possible. We often take water for granted until it runs dry. But what if the simplest solution to the water crisis is using less? Water conservation isn't just about shorter shower or turning off the tap. It's about rethinking how we use water in homes, farms, and factories. It's no longer optional, it's a necessity. Many cities in the world are updating plumbing standards to promote low-flow toilets, faucets, and shower heads. Countries like Australia have cut water use per person dramatically without sacrificing quality of life. And farmers, they're switching from inefficient flood irrigation to drip and sprinkler system, which dramatically reduce water waste. Small changes at scale can save billions of liters. Every time it rains, billions of liters of water run off our streets, rooftops, and pavements, washed away and wasted. But what if we could capture that water before it flows into drains? Stormwater harvesting is a powerful, underused solution in the global water puzzle. By collecting and storing the stormwater, we can reduce flood risks, recharge groundwater, and provide a valuable alternative to freshwater for non-drinking uses. Cities like Melbourne, Singapore, and Los Angeles are already turning stormwater into a resource, using green roofs, permeable pavements, and underground storage tanks. In a world facing water stress, every drop counts, and stormwater might just be one of our most overlooked answers. The other game changer is the on-site rainfall harvesting. From simple rooftop tanks in rural India to larger-scale underground cisterns in Australia, capturing rain is helping communities survive long dry seasons. The harvested rainwater can be used for irrigation and toilet flushing. Used water doesn't have to be wasted water. In many countries such as Singapore, industries are redesigning processes to recycle water internally. Singapore's New Water initiative purifies wastewater into ultra-clean drinking water, blending innovation with public trust. In places like California and Australia, recycled water is becoming part of the urban water supply for non-drinking purposes, proving that reuse is not a future trend, but today's necessity. And the nature. Sometimes the smartest engineer is nature itself. Restoring wetlands, reforesting watersheds, and protecting floodplains help store water, filter pollutants, and reduce flood risk, all while supporting biodiversity. In New York, preserving upstream forests has saved billions in water treatment costs. In Africa's Sahel, regreening projects are revitalizing dry landscapes and reviving local water cycles. Nature isn't just beautiful, it's powerful. In the digital age, data is as valuable as water itself, and technology is transforming how we understand, manage, and protect it. AI and machine learning techniques are helping us forecast droughts, floods, and consumption patterns with unprecedented accuracy. These models analyze years of historical climate and hydrological data to simulate future scenarios, allowing engineers and decision makers to act before a crisis unfolds. Internet of Things or IoT sensors now monitor real-time water levels in reservoirs, detect pipe leaks, and track soil moisture in fields. In cities such as Barcelona and Melbourne, smart meters help reduce water losses and optimize urban consumption. Then comes the next leap, digital twins. These are virtual replicas of entire water systems updated in real time with data from the field. Utilities and engineers can test scenarios like system failures, flood, and droughts without real-world risks. Imagine knowing where a pipe will burst before it does, or how much to release from a dam to prevent downstream flooding. Countries like the Netherlands and Singapore are already deploying digital twins to simulate urban water flows, improve flood management, and plan infrastructure upgrades. Remote sensing and satellite data add yet another layer, letting us observe water availability, land use, snowpack, and even underground aquifers on a global scale. Platforms like NASA's GRACE or Google Earth Engine are powering tools that detect droughts and water misuse, all from orbit. Technology is only part of the solution. Without the strong policies and sound governance, even the most advanced systems can fail. We need policies that reflect the true value of water, not just as a commodity, but as a critical, life-sustaining resource. That starts with pricing water responsibly, pricing that accounts for scarcity, incentivizes efficiency, and discourages waste. In many places, water is underpriced or even free, which sends the wrong message that it's limitless. Smart regulation means enforcing groundwater extraction limits, especially in regions where aquifers are drying up. It means prioritizing equitable access so that everyone, from rural farmers to urban slum dwellers, has a fair share. Citizens can be encouraged through tax breaks or rebates to adopt water-saving appliances, fix leaks, and recycle greywater. And let's talk about pollution. Too often industries discharge waste into rivers and lakes with minimal oversight. We need strict enforcement, real-time monitoring, and penalties that deter environmental damage, not merely serve as a cost of doing business. But it's not just about enforcement, it's about alignment. When policy lags behind science, mismanagement flourishes. But when aligned, policy, science, and technology become powerful partners in solving the water crisis. We need bold leadership, guided by evidence, driven by equity, and built for resilience. Because water isn't just a technical problem, it's a political one too. Finally, no solution works without people. Water literacy must be part of our culture from classrooms to boardrooms. Citizens who understand the issue are more likely to conserve, vote for sustainable policies, and hold institutions accountable. Programs in school, awareness campaigns in communities, and transparent communication all help turn passive users into active water stewards. So, will we run out of water? Technically no, but practically yes if we keep mismanaging it. The challenge is real, but so is our capacity to meet it, smarter than ever before. From harvesting rain to rethinking treatment, from cloud-based hydrological models to digital twins, and from restoring nature to empowering people, we already have many of the tools we need. However, we should admit that technology alone won't solve the water crisis. But combined with good governance, local knowledge, and community engagement, it becomes a force multiplier, one that gives us speed, precision, and power to face a rapidly changing world. The water crisis isn't just a story of scarcity. It can be a story of smart solutions, shared responsibilities, and collective hope. Thanks for watching this video. If you found it insightful, please give it a thumbs up, share it with your friends, and subscribe to our channel, Water Edu Hub. I'll be bringing more content on water, sustainability, and climate, and if that's your thing, hit the bell to stay informed. Let's keep learning, stay empowered, and take action together.